Hello, welcome to Spectacular Science Water Wonders. This video is to help you teach children about the scientific principle of surface tension, as well as to give them some fun and interactive hands-on learning. So here I have my example children, and to begin this lesson, I would start by getting their attention through this fun little story. Once upon a time, there was a giant with a beautiful, clean water bowl. And he loved his beautiful, clean water bowl. He thought it was fabulous, and he was kind of picky. He really liked things to be clean. But one day, when he wasn't looking, the pesky pepper people came. And they went swimming in his beautiful, clean water bowl. And when he saw that, boy, he was not very happy. And he did not know what to do about it, didn't know how to get rid of the pesky pepper people. So he went down the street and he went to his friend the magician. And the magician said, I'm going to give you this magical liquid. And if you drop it right in the middle of your water bowl, all of the pesky pepper people will disperse. And we'll go to the edges and we'll swim right out. And it works just like magic. However, it's not magic, it's actually science. And to understand how and why it works, you need to understand a little bit about water and about how water is made up. So I'm going to ask you a question. Who knows what Legos are? You guys know what Legos are? Do you like Legos?
Yeah.
What do you do with Legos?
You build things.
You build things with them, and all the Legos are different. Some are different colors, some are different shapes. Well, just like Legos, the world around us is made up of smaller building blocks. Just about everything you see is made up of building blocks that we call molecules. Now, an aside to the teachers here, you notice I said just about everything. It's written here on our poster as well. Just about everything you see around you is made up of smaller building blocks called molecules. Now, we didn't say absolutely everything around you, because there are some things around you that are made up of pure elements and not built by molecules. And so if you have an older audience, you can explain that because they might already know what atoms are. And you can explain, well, atoms make molecules, molecules make just about everything else. But if you're teaching a younger audience, rather than throw two new vocabulary words at them, we just stick with molecules. So the water molecule kind of looks like this. You know how Legos have different colors and shapes? Well, a water molecule, if you could look really, really, really closely, would kind of have this shape. And that shape and the things that make up that water molecule make it so that all the different molecules kind of want to pull together. Go ahead and show me your hands pulling together. So the water molecules kind of have this attraction to each other. They tend to pull to each other and want to be close to each other. And because they do that, they form kind of like a skin almost. Go ahead and rub your hand, rub your arm. That's your skin. Your skin's on the outside of you. It holds you all together. Yeah, you can pinch it, you can pull on it, and it kind of holds everything in. Well, surface tension is a little bit like that skin. It's not nearly as strong as your real skin, but it is strong enough that it can hold up a water skipper. You can see right here how this water skipper, you can see how it's kind of bending the water almost. It's because the surface tension is holding it up. Surface tension also causes water to form into a drop. Here in space, it makes a perfect sphere when there's no gravity. Now again, for older children, this is a time you can point out why it makes a sphere. If somebody asked, you can explain how the water molecules pull into each other. They want to be close to each other. Well, if it made a shape like a cylinder, like we have here, you'd see that the water molecules up here wouldn't be very happy. They're not all that close to everybody else, are they? Right? Same if I made a pyramid or any other shape like that. There would be a point where there'd be very unhappy water molecules. And what they would do is they would pull into each other until all the water molecules were as close as they could collectively be, and what you end up with is a sphere. So that's why water forms a sphere. is because of that surface tension that pulls it into itself, that wants those molecules to be close to each other. It makes that skin on the water. That skin is what held up the pepper people. Now the reason this experiment worked is because soap disrupts that surface tension. It breaks apart that pulling together attraction. And that's why the pepper people, they kind of pushed away as they stayed floating on the intact surface tension, and that kind of pulled to the edges of the bowl and left in here where the surface tension had been disrupted. This is why you use soap in order to clean your hands. The soap kind of helps break up things so that you can get more off of your hands than you otherwise would. Okay? So again, this attraction is called surface tension. We call it skin on people, but scientists have chosen to call this phenomenon surface tension. It actually happens in other liquids as well, but not as strong as it does in water, again because of this shape and the type of molecules that make up water. Again, it kind of like your Legos are all different and special, and they can build certain special things, same with the way the water molecules allows it to make this strong phenomenon called surface tension. Alright, so now it's time for the fun, interactive, hands-on learning where we use surface tension to try some different fun experiments. So the first one we have here is make your own maze. Now, if you are helping out at the Pioneer School Science Spectacular, there will be instructional cards for every activity. In this one, you begin by having children draw a maze onto the piece of cardboard or foam board, and then cover that with a piece of wax paper. I'm going to take that. Okay. And then because water forms a drop, we're going to put a drop right here on the start, and then we're going to guide it through the maze. So kids can make mazes as complicated or as simple as they like, and then they can practice guiding that drop through their own maze. So that is make your own maze, and it uses the fact that surface tension causes water to form a drop. Now we're also going to see kind of the drop shape in our next experiment. Now with this experiment, I want to stress the importance of, as for all science experiments, no matter how simple they may seem, always trying it out beforehand. Because your penny might have a nick in it that you didn't realize. I had a pipette that was dropping really large drops and kind of throwing things off. So always give it a try beforehand. So this one we're going to count how many drops we can get onto our penny, and we're going to notice the shape as you can kind of see the surface tension pulling that water together. Okay, ready? My helpers want to count with me? Mm-hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 13. So normally we get a lot more, so I'm going to try it again. I'm going to try it one more time. And we're going to count one more time. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I'm going to slow down. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. And I'm actually going to stop there. So there we go. So like I said, you like to try it out a couple of times. There might have been some water on the table. And again, because water likes to pull to itself, it might have been pulling off of the penny. And that's why we stopped so soon. But you can see kind of the bubble forming. Now we're going to compare that bubble to the one formed when we use soapy water in our cup B. Okay? So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11. So there, that one you can very clearly see the difference. Now my drops were bigger, so I would have gotten more drops if I'd done smaller drops. But even without that, you can see the difference. The big ball kind of that formed there, where you can see it. And here it was just very flat. And you can definitely tell the difference when the surface tension has been disrupted. Okay, so then we're going to move on over here to our soap boat. Now this experiment is really fun, however the water has to be reset every time. So it might not be a bad idea to have a couple of students go at once and see if they can race their boats. So they paint a little bit of soap onto the back of your boat. There's a little, you can do a little notch. You can do just about any shape of boat that you like, but this helps if you're doing a large group to show where to put the soap. Okay, so you two want to put your little boats in? Let's see, you can do that one. So on 3 and we'll have them race. 1, 2, 3, go. Woo! All right, so you can see them really take off there. And again, the way this works is that the surface tension is disrupted. So just like the pepper, the boats push forward and kind of skim along the front where the surface tension has not yet been disrupted. And that kind of keeps them moving forward. Again, this one has to be, water has to be reset every time. So for a large group, you might want to have one volunteer just doing that, or have lots out and have 2 or 3 kids go at once, or have bowls and pitchers there so that parents can help replace the water themselves. And our final one here is our paper water skiing. Now this one is a really fun activity, takes a little bit of practice. This is a good one to show that surface tension, though it can do some amazing things and is a strong force compared to some other liquids, it's still very weak compared to something like actually holding your hands together or your actual skin. And so to get something to balance on that surface tension, to have the surface tension hold it up, you have to kind of very gently and carefully get your water skier in just the right place. And then if you do it right, you can actually blow on the back. You want to blow on the back and get them to go. You can actually have them ski through the water until the water's absorbed into the paper and then the whole thing sinks. Oops! Or you blow too hard and it falls over. Okay? So that's a really fun one, and it will usually take the kids a few tries. The best one I've found so far is to have the paper clips on like this and the feet bent like that. And that seems to be the best, and the paper's got to be very dry for it to work. Go ahead if you want to give it a try. So this is one the kids can take a little while trying to get it to work. Very good, very good. And you can have 2 or 3 do it at once. Oops. So you can see how she put the paper clips in like this, and that kind of broke the surface tension. It really has to be very, very flat for the paper clip to be held up. It's got to be absolutely flat. If you place it in like this, it'll sink right to the bottom. Okay? So again, this is working with the surface tension, whereas putting it straight in breaks the surface tension, it sinks right to the bottom. Okay? All right. So that concludes our interactive activities for playing with surface tension and learning about surface tension.